Okay, so now let's have a look at the 2020 Higher Level Leaving Cert Maths Paper 1, question 9. So the number of bacteria in the early stages of a growing colony of bacteria can be approximated using the function n of t is equal to 450 e to the power of 0.065 t, where t is the time measured in hours since the colony started to grow, and n of t is the number of bacteria in the colony at time t. Find the number of bacteria in the colony after 4.5 hours. Give your answer correct to the nearest whole number. Okay, so this is just a direct use of the formula. So we're going to write down n of t is equal to 450 e to the power of 0.065. And we're told that the time is going to be 4.5 hours. So all we've got to do is put 4.5 in here. E to the power of 0. That should be t there, so it's 0.065, and we've got to multiply by 4.5 up here. Okay, so once you work that out, you should get 603. Okay, so that's part 1. Part 2 then, find the time in hours it takes the colony to grow to 790 bacteria. Give your answer correct to one decimal place. So again, this is just the use of the formula, so we need to write that down. We've got n of t is equal to 450 e to the power of 0.065 t. So this time we were given n of t, so we're told n of t is 790. I'm going to put 790 there and work backwards to find the time in hours. Okay, so the first thing you would do here is divide across by 450, so that will give you 79 over 45. Next thing you would do is just get the log of both sides, so we're going to get the log, we use the natural log of 79 over 45. And if you get the log of the right hand side, it just gives you the power here, so it's going to be 0.065 t. Next thing you do is just divide across by 0.065. So the next thing we're going to do is just divide across by 0.065. So if you divide the left hand side by 0.065, you'll get 8.65823, 65823, and so on. It goes on for a while, and then we get t on the right hand side. Now we're asked to give your answer correct to one decimal place, so that just means t then is going to be equal to 8.7 hours, and that's to one decimal place. Okay, so that's part 2. Let's have a look at part B then. Using the function n of t is equal to 450 e to the power of 0.065 t, find the average number of bacteria in the colony during the period from time t is equal to 3 to t is equal to 12. Give your answer correct to the nearest whole number. So in this case we've got to use the average value formula. So that's just going to be 1 over 12 minus 3. And then we've got to find the integral of our function from 3 to 12. Our function is 450 e to the power of 0.065 t. And we're integrating with respect to t. Okay, so this is what we've got to do. So let's work through that. I'll just work over here. So that's just going to be 1 over 9. Now I'm going to take this 450 outside the integral here. So, and put it over the 9 on the bottom here. So I end up here with 450 over 9. And then I'm going to integrate my function, the remaining part of the function here, which is this part here. So let's integrate that. Well, e to the power of 0.065 t will integrate as e to the power of 0.065 t, and because I have this 0.065 here, if I was to differentiate this function, I would end up with an extra 0.065. So I've got to get rid of that, and the way I'm going to get rid of that is divide by 0.065 here. I'm integrating between 3 and 12. Okay, so next step then is just to put in my limits and subtract. So I end up here with 450, which is 450 divided by 9, which is really just 50. And then inside a bracket here, I'm going to have 1 over 0.065 e to the power of 0.065. I'm going to put the 12 in here, and then subtract the same again with the 3 substituted. 0.065 e to the power of 0.065 here. This time substituted 3 in, so that's what I've got to do. Now when you do that, then you have the 50 on the outside, that's multiplied then by all of this on the inside. Now that's all really just calculator work. You can do all of this on your calculator, but what you get when you do it anyway is 14.864 01968 01968, and finally then when you do that you get 743, and that's to the nearest whole number. Okay, and that's it. So the average number of bacteria in the colony during the time period 3 to 12 hours is 743. Okay, so part C then is the next one. So let's see, find the rate at which n of t is equal to 450 e to the power of 0.065 t is changing when t is equal to 12. So at the 12th hour, 12 hours after they start, what is the rate at which the number of bacteria is changing? Give your answer correct to what is it, 1 decimal place. Interpret this value in the context of the question. Okay, so what we've got to do is differentiate our function. So we've got n of t is equal to 450 e to the power of 0.065 t, and we have to differentiate this function. So we have n prime t is equal to 450 e to the power of 0.065 t. E to the power of something when you integrate it is just going to be e to the power of something. But because we have another function of t up here, we've got to differentiate that as well. So we end up multiplying by 0.065 as well. So when you do that, you get 29.25 e to the power of 0.065 t. So that's our n dash t here. Okay, now we were asked to do n prime 12, so we got to put 12 in here. So just put 12 in here instead of t, and what you get there then when you do that again, that's just calculator work, you get 63.8. 63.8. What does that mean then in the context of the question? So what it means is the number of bacteria is changing at a rate of 63.8 per hour at hour 12, and this is after they start. So at hour number 12, the rate is changing by 63.8 bacteria per hour. At hour 12, in other words. Okay, so that's part C. So let's have a look at part D. After k hours, the rate of increase n of t is greater than 90 bacteria per hour. Find the least value of K where K is an element of N. Okay, so in this particular case we've got to write down our rate of change function, which is 29.25 e to the power of 0.065 K. This is n of t, n dash t. This is n dash t. Now this is the rate of change of the bacteria at a particular time. So we want this to be greater than 90. That's what we're given in the question here. So after K hours, so K is substituted in here for T, the rate of increase is greater than 90. So this is our inequality that we're going to have a look at here. So let's work through that then. First thing we can do is divide across by 29.25. So that will give us e to the power of 0.065 is greater than 90 over 29.25. That actually simplifies to 40 over 13. Now again, just get the log of both sides. So if you get the log, this should be 0.05k I should have here. So get the log of the left hand side and you get 0.065k, and also get the log of the right hand side. We'll just write it in, 40 over 13. Next thing you do to find k then is just divide the left and right hand side by 0.065. So if we do that, we have log 40 over 13 and we've got to divide by 0.065. So that means K has to be greater than 17.29. It goes on after that. Now what we have to do here is find the least value of K, where K is a natural number. So in other words, our answer here is K is greater than 17.29, so that just means K must be equal to 18 hours. Because K is a natural number, and the next natural number bigger than 17.29 is 18. So this is our answer here. Okay, so that's part D. Let's have a look at part E. The number of bacteria in the early stages of a different colony of bacteria can be approximated using the function p of t is equal to 220 e to the power 0.17 t, where p of t is the number of bacteria and t is measured in hours again. Assume that both colonies start growing at the same time. Find the time to the nearest hour at which the number of bacteria in both colonies will be equal. So we've got to make these two functions equal. So in other words, we have 220 e to the power 0.17 t, and we want that to be equal to our original function, which is 450 e to the power 0.065 t. Okay, so the first thing I'm going to do here is divide across by 220. So that will give me e to the power 0.17 t here, and 450 over 220. Next thing I'll do is just bring across the e to the power 0.065. You could do all these in one go if you like. So on the left hand side we'll end up with e to the power 0.17 t divided by e to the power 0.065 t, and 450 over 22. We'll just simplify that to 45 over 22. Okay, so on the left hand side we have e to the power 0.17 t minus 0.065 t. You just subtract the powers there, it's one of the rules of indices. We have 45 over 22 here, so that gives us e to the power of 0.105 t, and then on the right hand side still we've got 45 over 22. Okay, get the log of both sides, get the log of the left hand side. The natural log of the left hand side will be 0.105 t. Get the log of the right hand side, 45 over 22. And second last step then really is just divide by 0.105. Divide both sides by 0.105. Okay, so when you do that then, you'll get t is equal to 6.8. That goes on for a while as well, and we finally end up with t is equal to, now we're asked to find the time to the nearest hour, then. So if we have 6.8 here, it's 7 hours, and that's to the nearest hour. Okay, and that's it for this particular question.